Hello, are we live? Like, is it streaming started? Hello, hello, hello. Okay, yeah. So let us start with the thing. So we'll do a bit revision of what we have on the big three, right? So mainly the questions where you have to solve some kind of problem. So we'll just see all those type of how to approach those kind of problem and how to solve them. So let me share my screen. Okay, I'm using the same presentation what is used in the lectures. So let's go for the first slide. Okay, so this is an example like where you will be given with a code and you have to draw. You have to draw a CFG, and on the CFG you have to apply different kind of coverage criteria for deriving the test cases. So there are different cases over here. You can study yourself. So I'm not going for it. So you have to practice this thing. So I'll directly go for the problem which is solved inside this particular slide. So this is this code, right? So for this, we need to draw a CFG, and also we have to apply the edge coverage, then edge pair coverage, and the prime path coverage. So let us check out this. Okay. Okay. Give me a moment. So first of all, like what I want to do, I want to derive a CFG for this. Okay. So what I'll do, I'll draw the corresponding CFG over here, right? For this particular code. Okay. So first of all, whenever you're having a number of statements without any branching or looping, like if you consider this much of the statement, we can say this is as a basic block. We can just represent them as a single node. We can just represent them as a single node inside our graph. So let us create the first node. So this is my first node. I marked it as a 1. Let me do it a bit clean way. So this is a node, right? So this is 1. So what this represent? This represent all these 3 statements. So they are consecutive statements without any branching or looking kind of thing. So I can just have one node and I'll basically call it as a basic block. Whenever you're having a for loop, this initialization happens only once, that's at the beginning. Then the testing happens, then the execution, increment, following by again the testing of the condition, right? So how we can do it? So there could be 2 things. Either this condition matches or it do not match. But first we need to represent the initialization. So how do I do it? So I can have another node, that's a node 2, which is representing this I equal to 0. This is this I equal to 0. Now for decision, for the condition making here, for condition making, you can use a dummy node. So normally we use a dummy node over here. So in which one side will be where the condition is true, another side will be what will happen if the condition is false, right? But it minimum 2 branching, but it could be more than this branch, because you can understand there could be like if, else if, then else kind of thing, right? So what we can have, if the condition is true, that's if I get I less than what? I is less than length. And this portion will be if I is greater or equal to given length, right? So if this condition is true, so let us go into a node called as a node 4, right? So in node 4, what we do? So node 4 basically takes care of this particular statement and also this increment. Then after increment, it comes back to the condition once again. So it's a looping. If the condition is true, again it will be repeated. If the condition is false, so it will go on, the particular loop will terminate. So I'll go to another node, that's a 5. So this will happen whenever the condition is false. Okay. So next what I do again, Now I again have basic blocks and also the initialization. So what I can also do, it may be two nodes, like the basic block up to this and the initialization. Or what I can do, I can also assume that this I equal to 0 also part of a basic block. I can see these are three along with I equal to 0. These are a consecutive statements without any branching or something. So one way you can have two nodes, one is for this, another is for this, or you can merge it into a single node. So a CFG for the code could be written in a different ways, but important is it should provide the same structure. So that's the thing. Structure in the sense the branching, looping, this kind of structure should be similar. So let us merge it into a single node. So what I can have a this 5, where basically I have the basic block statement and this I equal to 0 also, right? Then I can have again a dummy node which takes care of the branching, Where is the branching? Here is the branching, right? This checks for a condition. If the loop condition is true, what I'll do. If the loop condition is false, what I shall do. So let us again, it's basically generate two branches. One is for true. True when I is less than length, and false when I is greater or equal to length, right? Now, if you look at the code, if this is true, I'll execute this statement, I'll increment, and again I'll come back to the condition. So I can have again here a 7, and from 7 I'll loop back over here. Now if the condition terminates, I have to execute this many statements. So these are again consecutive statements. I can just assume these are a basic block and I can take only one node for them. But this ends your execution. So this is a final node. So final node means you put it in a double circuit. So this is ultimately presenting your entire CFG. So this is the CFG for this particular code. Okay. Now I have to apply different criteria. So first, so node coverage is trivial. I may not have to do it. So just for to have the total coverage of the things, let us also discuss that. So if I have to do a node coverage, so what is my test requirement? What is my test requirement? So I need to cover node 1. I have to cover basically all the nodes. Then node 2, node 3, node 4, node 5, node 6, node 7, node 8. Right. Now, what could be your test path? I can just have one run inside the entire graph CFG to cover all the nodes. What I can do, what should be my path? I can go to 1 to 2. I can go from 1 to 2, from 2 to 3, 3 to 4, then back to 3, then go to 5, go to 6, go to 7, go to 6 once again, go to 8. So done. So if you look at, I follow the path like this: 1 to 2, 2 to 3, 3 to 4, 4 to 3, 3 to 5, 5 to 6, 6 to 7, 7 to 6, 6 to 8. So done. So do I cover everything? So how to check it? Like I need to cross check. Do I cover this path cover every node? For node, it is quite simple. So one, if it is there, yes, one is covered. Two, is it covered? Yes. Three, is it covered? Yes. Four, is it covered? Yes. Five, is it covered? Yes. Six, is it covered? Yes. Seven, is it covered? Yes. Eight, is it covered? Yes. So we are done. So this is the simple way to do the node coverage, which is quite simple, right? Oh, let us go for edge coverage now. Edge coverage. So I have a edge coverage criteria. So what is my test requirement? So I need to consider all the edges, right? So let us take edges from one. From one, I can have one, two. From two, what I can have? From two, I can have two, three. From three, what I can have? From three, I can have three, four. I can have three, five, right? From four, what I can have? From four, I can have four, two, three. Then from five, what I can have? From five, I can have five to six, right? Then five, anything else? No. From six, what I can have? I can have six to seven, right? Then we can have six to eight. From seven, I have seven to six. So these are my edges. So let us just cross check. One to two, two to three, three to four, three to five, four to three, five to six, six to seven, six to eight, seven to six. Done, right? So now let us find out test path, one or more paths. It should be actually a paths, right? Set of paths it could be. So in this case, eventually we are having just one path, but it could be more than one path also. So what could be your test paths? Okay, let us find it out. It's quite intuitive, right? So if I start from one and just try to cover every edges and reach the eight, how do I do it? So I'll just show how I do it. There is nothing like it's a fixed kind of thing. So it's a one and two. Now I'll check out what is starting with two. I can say from two, I'm getting a three. Now anything starting with three, it's a three. So from three to four. From four, what I can get? From four, I can getting a three. So with three, now I can go to five. From five, what I can go? I can go to six. From six, where I can go? From six to I can go to seven. From seven, where I can go? From seven, I can go to six. From six, where I can go? I can go to eight. So it's done, right? So let us check, is it correct or not? So do I cover the age one to two? One, two, right? So one, two, is it there? Yes, one, two is there. So it's covered. Do I cover two, three? Yes, two, three is also there. Do I cover three, four? Yes, three, four also there. Do I cover three, five? Yes, three, five is also there. Do I cover four, three? Four, three is there. Do I cover five, six? Yes, five, six there. Do I cover six, seven? Yes, six, seven there. Do I cover six, eight? Yes, six, eight is there. Do I cover seven, six? Yes. You can see, it's basically provide edge coverage criteria also. And in this case, eventually we are getting the test path for node coverage and edge coverage is same, but it may not be same. So we say edge coverage conforms to the node coverage, but node coverage may not conforms to the edge coverage, right? Just a minute. Okay, so next, what we have, we are having the H pair coverage, right? So what you can do for the H pair coverage. So H pair coverage. So this is the criteria. Okay, so what is my test requirement? So I'm writing over here, right? Test requirement. Okay, so H pair, right? So I have to consider this 1, 2, 3. Okay, from 1, anything else? No. From 2, what I can get? From 2, I can get 2, 3, 4, right? 2, 3, 4. I can get also 2, 3, 5. Okay. From 3, what I can get? I can get 3, 4, 3, which is a loop. I can also get 3, 5, 6. Right? Then with 4, what I can get? I can get a 4, 3, 4. I can get a 4, 3, 4. Right? Then with 5, what I can get? Let me write it properly. Otherwise, whenever I'll take it down, maybe it gives me a lot of trouble. So 4, 3, get it 4. Okay. So 5. So 5, I get 5, 6, 7. Then I can get it as a 5, 6, 8. Right? So from 5, these two only. Then using 6, what I can get? I can get 6, 7, 6. There is no more than the H pair, right? Then from 7, I can get 7, 6, 7, right? So 7, 6, 7, I can get also one other, that's a 7, 6, 8. So let me cross check it once. Okay. So from 1, I can get only 1, 2, 3, nothing else. 1, 2, 3. Okay. From 2, I can get 2, 3, 4, right? I can get 2, 3, 5. Yes. From 3, I can get 3, 4, 3. Okay. I can get 3, 5, 6. 3, 5, 6. Right. Then I can get using 4, what I can get? Using 4, I can get a 4, 3, 4. Yes. Using 4, I can get also 4, 3, 5. This is I haven't written. I have to write it, right? So one is missing. I can also have 4, 3, 5. So this is why the cross checking is required, right? So it's a 4, 3, 4, 4, 3, 5, right? Then I can using 5, I can have 5, 6, 7, 5, 6, 8. Using 6, I can have 6, 7, 6. I can have 6, 7, 6. That's all. Using 7, I can have 7, 6, 7 or 7, 6, 8. Right? So these are my test requirement in case of H pair. Okay. So let us go for having the path, right? So I want to write it over here. Otherwise, uh, I cannot see the CFG. It will be difficult. So I'm erasing this portion and I'll be using this portion to write the path, test path. Because without seeing the graph, it is a bit difficult. Okay. So for this, I want to find the test path. Test paths. Okay. So what I do actually, I start with 1. So 2, 3. 1, 2, 3. So let us check, do I have anything starting with 2, 3? So I am having 2, 3, 4. So here there is a 3, 4. Is there anything starting with a 3, 4? Right. So you can see here this is starting with a 3, 4. So it will give a 3, 4, 3. Right. So this is 4, 3. So if you look at over here, it's a 4, 3, then 4. So it's ending with a 3, 4, right? It's ending with a 3, 4. So with a 3, 4, what I can get now? Using 3, 4, what I can get now? Using 3, 4, I can get only this, right? 3, 4, 3. So that's again 3, right? Now 4, 3, what else I can have? 4, 3, I can have this 5. Then with 3, 5, what I can have? With 3, 5. Let us check out if I have starting something with a 3, 5. Yeah, 3, 5 here. 3, 5, 6. Now this is ending with a 5, 6. Do I have anything starting with a 5, 6? So this is starting with a 5, 6. So it goes to the 7. Now anything starting with a 6, 7. Let us find out. This is starting with a 6, 7. Right? So it's end up 6, 7, 6. So it's ending with a 7, 6. Anything starting with 7, 6? This is starting with a 7, 6. So it's a 7, 6. Again 7. Right? It's a 6, 7. So 6, 7. Again it gives you a 6. It's a 7, 6 now. So 7, 6, I took already this. I can take this one now. So this 7, 6, 8. So I reach the end. But I have to check, do I cover everything? So you can see I've covered most of the thing, but two things are left, this and this. So for this two, I need to take another path. So let us just find out which path we have selected right now. If I go for this, it's a 1, 2, 1, 2, 3, right? Then have gone for 4, right? Then again 3, again 4, 3. So I'm repeating the loop twice. Okay, then I have gone for 5, then have gone for 6, then 7, then again repeating it 6, 6. So I'm repeating the loop twice, then I go to 8. So basically it's taken this particular path, right? But I yet to cover these two. So I have to take right now another path so that I can cover this also. Right? So let us go for a path. So I have to go to 2, 3, right? So I have to definitely uh, start with 1, 2. I can go to this 1, 2, 3 basically. But from 2, 3, I'm not going for this because this is already taken. Rather, I'm going to 1 to 5. 1 to 5. Now 1 to 5, sorry, 1 to 3, 5. So it's a 3, 5. So with 3, 5, where you can go, with 3, 5, you can see you can come to the 6. So this is the path. This is the path. So using 5, 6, what you can do, you can go this path, you can go to 8 directly, right? So this could be another path. So how this path goes? So this is 5, 6, 8. This is also covered eventually, right? So how this path will go? So let me take a different color for better understanding. So if I check out this path, so it basically goes for 1, 2, 1, 2. Then we are going for 2, 3, 2, 3. Then we go for 3, 5. Go for 3, 5. Then we go for 5, 6. Then 6, 8. But we need to also test, do I cover everything or not? So that's very, very important. Okay, so 1, 2, 3. Is it covered? Yes, it is covered. You can see 1, 2, 3 is there here. Right? So 2, 3, 4. Is it covered? I can get 2, 3, 4 here. So it's covered. 2, 3, 5. Right? 2, 3, 5. 2, 3, 5 getting covered here. 3, 4, 3. 3, 4, 3. So it is covered here. Okay. 3, 5, 6. 3, 5, 6. You can see here. 4, 3, 4. 4, 3, 4. 4, 3, 4. It is here. 5, 6, 7. 5, 6, 7. It's here. So it is covered. Now I have 5, 6, 8. I'm having 5, 6, 8. Where it is getting covered? It is getting covered over here. Right? Now we are having 6, 7, 6. 6, 7, 6, which is getting covered here. We have 7, 6, 7. 7, 6, 7. We are having 7, 6, 8. Yes. We are having 4, 3, 5. Yes. So you're getting everything is covered. So this is the correct test path, and this is the test path for which coverage? This gives you a H pair coverage. But you can draw your test path in a different way. You can get 3 test path or 4 path. It does not matter, but ultimately whatever the path you are getting, it should cover all the test requirements. So here the H pair, whatever you are getting over here, that is your requirement. That has to be good. Okay, so now we go for the next one, which is the prime, right? Prime path. So I'm erasing this because I have to use the image here, what I have drawn, the graph rather. So without that, it's quite difficult to do the thing. Okay, so let me start it. So we are going for a prime path coverage. Okay. So first, we need to derive the test requirements or the prime paths, right? So what is the way we have to do it? Last I have shown some example. So I'm going for it once again. Okay, first we say we have to determine what are your L0s, right? The path with 0 length. So that's basically our nodes. So we have to do 1, we can take 2, we can take 3, 4, 5, so 5, 6, 7, 8. If you have 8 nodes, your length cannot be more than 7. So maximum I have to go for L7, right? So I put exclamation marks over here because this is my end node, right? So I cannot extend basically this node. Extend my path from that node. Okay. So what will be the L1? From 1, what I can get, there could be only one path, that's a 1, 2, 3. There cannot be any more path than this. Then for 2, what I can get? From 2, I can get only one path, that's a 2 to 3. That's all. From 3, what I can get? From 3, I can have 3 to 4. Right? And also I can get 3 to 5 as well. Okay. Now from 4, what I can get? From 4, I can get 4 to 3. From 5, I can get 5 to 6. From 6, I can get 6 to 7. Right? From 7, I can have, okay, 6, I can have another path. I can have 6 to 8 also, which is the terminate end node. Then from the 7, I can have 6. From 7, I can have 6, right? From 8, I cannot extend. So that's all. So I get this many path, which is of length 1. So I have to go for now L2, length 2. So with 1, I can get only 1. That's a 1, 2, 3. Now from 2, 2, 3, 4, right? Then from 2, what I can get? I can get 2, 3, 5. Okay, 2, 3, 4, 2, 3, 4. So if you look at this particular path, this 2, 3, 4, it's having a significance. If you try to extend this, it will come back to 3. So it will become 2, 3, 4, 3. So 3 will be repeated, right? So that cannot be a simple path, right? That won't be remain as a simple path. So this 2, 3, 4 is a path which will end over here itself. It cannot be extended, right? So I've just put a this exclamation mark over here. But 2, 3, 5 can be further extended. Now what about this 3, 4? The path 3, 4, it could be 3, 4, 3. So put a star because it's already a loop. It's already a simple path. So using 3, 4, can I have any more? No. Using 3, 5, I can have 3, 5, 6, right? I can have 3, 5, 6. Can I have anything about with 4, 3? Let us check out. Using 4, 3, I can have 4, 3, 4, which is a loop, which is itself is a simple path. And we can have a 4, 3, 5. Okay. Now using 5, 6. Using 5, 6, we can have 5, 6, 7. We can have 5, 6, 8. Right? 5, 6, 8. Right? Then using 6, 7, what I can have? I can have 6, 7, 6, which is itself is a loop. I put a star, right? Okay, one thing, this 5, 6, 7, this particular path, if you look at over here, 5, 6, 7 cannot extend because the 6 will be repeated. So this path will end immediately here, right? Okay, from 6, 7, I'm having 6, 7, 6, which is a loop. With 6, 8, that's a end. With 7, 6, 7, 6, I can have 7, 6, 7, which itself is a loop. This is a simple path. And we can also have 7, 6, 8, which reach the end. Right. So this is my L2. Okay, so let me go for now L3. So I want to write my L3. Okay. So 1, 2, 3, that's open still. So 1, 2, 3, I can have 1, 2, 4. 1, 2, 3, 4. but that's ends, because if I want to extend 1, 2, 3, 4, again 3 will be repeated. That I cannot. Right. Now 1, 2, 3 can be also extended to 5. So 1, 2, 3, 5. Right? 1, 2, 3, 5. So this path is already ended. 2, 3, 4. So I'm not doing this. 2, 3, 5. I need to deal with this. 2, 3, 5. So if we look at 2, 3, 5, I can make it simply 2, 3, 6. 2, 3, 5, 6. Right. It can be still extended. Okay. 4, 3, 4. It's a loop. It's done. 4, 3, 5. What about 4, 3, 5? Using 4, 3, 5, I can go to 6 once again. 4, 3, 5. So 4, 3, 5, I can go up to 6. Right. Okay, haven't done this 3, 5, 6, right? So let me copy this 4, 3, 5 here, 5, 6. Because anyhow I have to take it, but before that, let me take this path also, which I have missed, that 3, 5, 6, right? From 3, 5, 6, where I can do 3, 5, 6, 7. So that's end over here, because if I extend, it becomes it do not remain a simple path. Or I can have 3, 5, 6, 8. That's also ends here. Okay. So 4, 5, 4, 3, 5, I have already extended. 4, 3, 5, 6. So these paths are already simple path. I don't have to do anything. Okay, so I have to go still for L4. So let me go for L4 here. So L4, I have to take this. 1, 2, 3, 5. 1, 2, 3, 5. That could be still 1, 2, 3, 5, 6. Right? Okay. So this still can extend, right? Now what about this 2, 3, 5, 6? 2, 3, 5, 6. This also can extend. So 2, 3, 5, 6. I can say 7. That's fine. But further I cannot extend. So this ends. And also I can have 2, 3, 5, 6, 8. That's also ends here. That's also ends here. Okay. These are already done. So this 4, 3, 5, 6, this path I have to deal with. So let us check out 4, 3, 5, 6, what I can get. This 4, 3, 5, 6, it could be 7. 4, 3, 5, 6, 7. But this reaches the end. Okay. Another path could be 4, 3, 5, 6, 8. That's also go for the end. Right. Now, which is still extendable? This particular path. Right. So I can still have a L5. Okay. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 can go to 1, 2, 3, 4, 5, 6, 7. That ends here, because if I do this, the 6 will be repeated. And I can have 1, 2, 3, 4, 5, 6, 8. That's also the end. Okay, so now let us find out the prime terms. So as you know, that we need to start with the path which is of the particular simple path which are having the highest length, right? Prime path. Okay. So if you look at here, the last one itself is a complete path here, right? because if you look at here, this 1, 2, 3, 4, 6, 8, that itself is a path from the starting to end. So we can take directly this as a test path 1, 2, 3, 4, 5, 6, 8. Okay. Now what I can do about this? So for this, I can have 1, 2, 3, 4, 5, 7, but I have to go to the end node. From 7 again, I can go to 6, then I can reach 8. Okay. So which are done, let me just mark it. So I have done this and this. These are covered, right? So next, what I need to cover? Okay. So 1, 2, 3, 4, is it covered? This 1, 2, 3, 4, yes, this is also covered. This is a simple path. Now again, this is a simple path, right? 3, 5, 6, 7. 3, 5, 6, 7. So this is not covered anywhere. 3, 5, 6, 7, right? So I have to have a path which will cover this 3, 5, 6, 7. So let us mark it first. 3, 5, 6, 7. So 1, 2, 3, 4, 5. Yeah, just I'm sorry. I think I have done some mistake over here. Just it's not coming as a proper path. Let me just go back to L5. There is some problem with the L5. Just I'll rewrite this because it's not a path actually what I have written. So which one I was extending? 1, 2, 3, 5, 6. Yeah, I just wrote 4 somewhere. 1, 2, 3, 5, 6. So 1, 2, 3, 5, 6 means it's taking this path 5, 6. Right. So I can go either to 7 or I can go to 8. 1, 2, 3, 5, 6, 8. So that's all. Yeah. These two are correct. 4 won't be there. So now I have to go for my prime points. Please do the correction. Okay. So what I told, like this 1, 2, 3, 5, the last one. If you look at this graph, this 1, 2, 3, 5, 6, 8. This itself a path from the starting node to end node. So I can directly consider this 1, 2, 3, 5, 6, 8. So there is no problem with this. But this 1, 2, 3, 5, 6, this is not covered over here. So I have to create another path to cover this. I'll have 1, 2, 3, 5, 6, 7. But this is not ending. So from 7, I can go to 6. Then I can reach the 8. So the first path, it basically skip all the loops. The second path, it's basically repeat the last loop once, right? I have to check out which are the simple path we have already covered. These two are covered. 1, 2, 3, 4. This is not covered, right? 1, 2, 3, 4. I have to cover. So 1, 2, 3, 4. So what I have to do to cover 1, 2, 3, 4? Let us check out. So if I have this 1, 2, 3, 4, then 4 to 3 I can go. Then 3 to 5. Then 5 to 6. Right? Then you can come 6 to 8 directly, or you can repeat once, then go to the 8. So if I repeat the loop, it will give a more coverage, but you can do anything, like it's nothing mandatory. So I'm taking a loop here, 6, 7, 6, 6, 7, 6. So I'm basically going for both the loops. Okay, 6, 7, 6, then 8. So it comes like this, it repeat this loop once, repeat this loop once, then comes to that. Okay. So 1, 2, 3, 4 is covered. Yeah. Now 3, 5, 6, 7. So 3, 5, 6, 7, you can see here. So this is covered. Now 3, 5, 6, 8. 3, 5, 6, 8. 3, 5, 6, 8. 3, 5, 6, 8. Yes, you can get it over here. So it's covered. Now here 2, 3, 5, 6, 7. 2, 3, 5, 6, 7. 2, 3, 5, 6, 7. You can get it here, right? 2, 3, 5, 6, 8. Right? 2, 3, 5, 6, 8. Yes. 4, 3, 5, 6, 7. 4, 3. Anything starting with 4, 3? 4, 3, 5, 6, 7. Yes. 4, 3, 5, 6, 8. 4, 3, 5, 6, 8. I don't think it is there because 4, 3, 5, 6, 8. It repeat this loop but skip this loop. You're getting the things how it is selecting. It select a path without any loop. Select when this loop is repeated once but this loop is skipped. Select this loop repeated once, this is skipped. Then select a path where both the loops will be repeated once, right? So this one I need to complete it, right? So I am having a 4, 3, 5, 6, 8. So I have to reach 4. So it's a 1, 2, 3, 4. So I have to just say 1, 2, 3, 4. Right. So it's done actually. Now you have to just check other paths. If something is not coming over here, you need to again create a path. But I think we have already done this, right? If it is something is missing, you have to add it. So let us just complete this. I think that's better. So it's a 7, 6, 8. So this is done. 7, 6, 7. So 7, 6, 7 is interesting. It is repeating the loop this twice. It's repeating this loop twice. So this is again a new path, right? So it could be 1, 2, 3, 5. 1, 2, 3, 5, 6, right? 7, 6, 7, because 7, 6, 7 is my criteria. 6, 7, 6, 7. So twice repeating, then go to 6, then reach 8. So skipping, repeating once, repeating twice. Then 6, 7, 6, 6, 7, 6. This is repeating once. That's, I think we have already done. Yes, we have already done. 5, 6, 8, 5, 6, 8. Skipping the loop. That's we have done. Somewhere we have done 5, 6, 8. Yes, we have done here. 5, 6, 7. 5, 6, 7 we had already. 5, 6, 7. We have to check out where it is. Yes, 5, 6, 7 is here. 4, 3, 4. This is again interesting. 4, 3, 4. This will be repeated twice. So you can go for 1, 2, 3. You can go for this 1, 2, 3, 4, right? 3, 4, right? Again 3, repeating twice. 5, 6, 8. So now you have to check rest of the thing. I think we have covered everything. So without any repetition of the loop, repeating one loop only once, repeating another loop only once. Like again, I say, skipping both the loops, skipping one loop, repeating one loop once, skipping one loop, repeating another loop once, then executing both the loop once, executing each loops twice. So that is the thing what I do. So this is what we have discussed here. So I haven't done anything with the DU path, right? Data flow coverage and all. So I'll just send you a mail today, like what is your requirement and how you want it to be scheduled and all. So please reply to that. And if you want a session, separate session for this data flow path to be covered, or if you want something to be discussed on practice questions, So we can also have a session separately, or what we can do, we can also do something on a discourse. If it's a simple kind of doubt, you can write a question and I'll answer that. So I think that's all for today. Thank you very much.